Today we will be discussing arithmetic sequences. Here are your objectives. I can identify arithmetic sequences. I can write an equation for the nth term of a sequence. Okay, we have a few definitions we're going to start with. Arithmetic sequences are sequences that have a constant difference between successive terms. So we know that term constant means the same, just like in a linear function. And successive just means in order. And common difference, which we're going to use lowercase d to stand for, is the difference between the terms. And we're going to be finding those throughout the lesson. Okay, so our first set of directions says determine if the sequence is arithmetic. If so, find the common difference in the next three terms. So you're going to be looking for a common difference, and so I know that to get from -4 to -2, I add 2. From -2 to 0, I also add 2, and 0 to 2, I also add 2. So because this is the same change happening each time, it is arithmetic. So we'll write arithmetic. And the common difference, which is lowercase d, is +2. And then it asks us to find the next three terms. And so I know that my next term would be 4, and then add 2 more, 6, and then 8. So our second example, we have 0, 6, 12, and 16. So I see that it is going by +6, and then again +6, and then again +6. And so yes, it's arithmetic. My common difference, or lowercase d, would be 6. And then my next three terms would be 24, 30, and 36. And so our last example, we have 1, 4, 9, and 25. I know that I add 3 and then add 5. Right away, I know this is not arithmetic, so we're going to write no. And we can stop there because there is no common difference. Okay, so here are some important things that you're going to want to jot down. We have the arithmetic sequence formula right here. We're going to use this to develop a generic formula for each pattern. And so each of these are important to know what they stand for. AN stands for any term. Our A1 we're going to use a lot today. It stands for our first term of the sequence. Our N is the term number, and D, of course, is our common difference. Okay, and so our first set of directions says write the equation for the nth term of the arithmetic sequence. So if I give you this sequence and I said, well, find the 100th term, you are not going to want to go through and figure out keep adding for 100 times. That is going to be a long process. So instead, we can write a generic equation using our formula that will work for any term number that you're trying to find. And so the first thing, you need to definitely find two things in order to write your equation. You always want to locate the first term and the common difference. And that's all you need in order to write your equation. From there, you just plug in any value and simplify. And so our A1, so let's identify those. So our A1 stands for our first term is -12. It's the first term of the sequence. Our D is our common difference. So let's see. Looks like we are adding 4 each time. So our D is +4. If it was subtracting 4 each time, it would be -4. And so now we just take our equation and plug in. And so we are going to leave everything the same except our A1 and our D. So we have A sub n. And then we know our A sub 1 is -12 plus, and then in parentheses we have n minus 1. We're going to leave that the same. And then our D, which is 4. So every time we write this, we're going to plug in those two things, the A1 and the D. And then we can simplify this because we know in algebra we like things simplified. So I'm not going to do anything with this A sub n, because that's just standing for the equation, the sequence. And so I notice that I can multiply here. This is kind of like a backwards distributing here. So I'm going to bring down my negative 12 plus, and then I have 4 times n, which is 4n, and then 4 times negative 1, which is negative 4. And then I look further and I see, oh, I have some like terms I can combine. So I notice I can combine my negative 12 and my negative 4. So I have a sub n equals 4n minus 16. And this is my equation for this sequence that if I want to find any term number, I can plug it into n, because n stands for term number, and find that term. So if I want to find the 100th term, I can plug in n and evaluate, and that will give me that term number. Which brings us to our follow-up question: find the 9th term of the sequence. So I can use my equation. I'm going to bring it down. A sub n equals 4n minus 16. And I want to find the 9th term. So a sub 9 equals, instead of 4 times n, I'm doing 4 times 9, because that is my term number is n, minus 16. Then I'm going to plug that in my handy dandy calculator and evaluate and get a sub 9 equals 20. So what that means is my 9th term of the sequence is 20. So I could have went through and continued to add 4, add 4, add 4 to get my 9th term, which wouldn't be too bad when we're talking about term number 9. But again, if we're trying to find the 100th term, that might be a little bit difficult. All right, here's a problem for you to try on your own. So use your notes that you just wrote down and give it a try.